Oh.
We have two people there who free.
Okay, then I'll
Prefer
switch.
English instead
Yeah,
of
sorry, the slides are most of them in Dutch, but well, I just do
You
my.
forgot to tell you, I guess.
Yeah,
Yeah.
sorry, totally
No,
slipped my
no
mind.
problem. I mean, I hope no problem. And otherwise,
And
we'll see.
if one of our English speakers says what concept of
Yeah. Well, I'll do my best. So, change your mind, but okay, let's see. Well, thanks for the invitation. I'm glad to come here to tell something about Ampersand and Haskell. The way, well, the way we use it. First of all, some questions. Who's heard of Ampersand? That's two. That's not very much. Okay, so there's something might be interesting. Who's heard of Haskell? Ah, that's good. More hands. Who's done something with Haskell? Okay, that's not bad. It's above my expectation. So
Who's
that's
done something like that correctly?
okay. Well, so let's move on. My name is Han Joosten, and I'm analyst with Edina. So in normal life, I don't write code, but beyond that, I'm a business engineer, analyst. I also work, well, started as a hobby, and now it's something, well, I'm not sure what it is, but we do cool things. I'm member of a team that does Ampersand task sheet. It's on Twitter, you can find it. And we create software that is ondersteund, that supports the Ampersand method really. So that's it's not for work yet, but well, certainly a lot of nice things to do. So this is what this talk is about. First, I'll introduce you what Ampersand is. Well, just high level, of course. The half an hour is not that long. We built the software that is supporting Ampersand mainly with Haskell, and that's not by coincidence. So I'll also tell, of course, a lot about Haskell, and finally I'll just have something to show the rest of the tooling we use to work with Ampersand. So, well, start with Ampersand. Ampersand is a methodology based on business rules to realize software that is compliant with these rules. Well, that's pretty ambitious if you look at it, because well, business rules are rules that are set up by well, strategy or law or whatever thing that a business wants to want to execute. And that can be illustrated by use of a kind of a example. It's in English, so that's not too bad. This is an example of a process that is totally defined by business rules. And we from Ampersand, we believe that processes can be defined and made executable not by by specifying BPMN diagrams, saying, well, first you have to do this, and then the next thing has to be done. And so some of you might be familiar with BPMN notation to specify what is done during the process. In fact, we believe these kind of business rules, they define the process. So the idea about Ampersand is that if you are able to grab these rules and make them explicit, then which is of course something that is really on the business side. There's no IT involved in getting these kinds of rules explicit. I mean, what the business wants to do, or what the process should be doing. That's no IT stuff. That's business stuff. On the other hand, the last 20, 30, 40 years, I mean, with the upcoming of automatization, we've seen that IT has, well, taken the power to do all kinds of things with business processes. And business has let that done. I think that if you can make it a good distinction between what the business has to do, defining what the rules should be for a process, and on the other hand, what IT should do, making this all work with good IT tooling and infrastructure and whatever goodies the IT has, then when we bring that together, we have something very good. I'm not going to dive into this much further because, well, it might be more for other audience. So what we, as a team at Ampersand Tarski, what we really want to focus about is the quality of the stuff. So everything we do is not based on deadlines and stuff like that, but well, we have very limited resources. That's the team, and most of us are just doing this for well, beside the real work. So there's very little resources. On the other hand, we really believe in this stuff, and so we want to get this right. So, well, quality is key. And we also think that it doesn't really matter what you're doing, what you're building, but the way the way you work and the principles you have, that's that make that the product you make in the end has a higher quality. So we really focus on the way we produce the software, the artifacts that we have. So on a very high level, the Ampersand tooling, what does it do? We start by some specifications. A specification that contains the rules, well, the business rules, and these are the, in fact, this is the model that some business engineer makes in, and he makes the business rules explicit. And this is done in two ways in the specification. All these rules are written down, well, one by one, in a declarative way, and well, it's double. People at the business side, we need to know. We need to know that the strategy is worded well. They can validate that that is And on the other hand, every rule is also written down um, in a formalism. And that's very handy because we all know that natural language, if you try to process natural language, that's pretty hard. And if you want to derive processes from it, well, that's probably no can do. So if you write it down in a formalism, then chances are much better that you can do nice things with it. So the formalism we use, we have a domain-specific language which everything is written down in, and the engine, the methodology is based on relatiealgebra, which is a formalism that's well known and which is great. A lot of that. So this is specification, it's a single source of everything we produce. Then there is a generator, which is just a piece of software which does a lot of cool stuff. And we have all kinds of outputs to derive from the specification. The first thing which is derived is just a document which is written in natural language, derived of course the natural language in these rules and stuff like that. And the audience for that document is the people at the business side. So there's no IT speak in the document, it's just business speak. Then we derive all kinds of models known in the IT, data models, well, all kinds of other logic specifications. So based on this, eventually a system could be built. And last but not least, we also derive a prototype, which is very good because the prototype ensures that the specification, well, it's buildable. I mean, so there's no guarantee that it could be built because we have a working prototype. And also these prototypes help people from the business to see pretty quickly what they will get or what the rules they define, what's the impact of it. So it's a rule to make sure that the rules they come up with are sufficient to derive the old process. So, enough about Ampersand, I think. So as I said, the quality is key. So to do this, you need a couple of, we have requirements. So we need that the entire stuff is possible to validate the model by the business. Well, we have that by document and of course the prototype we have. Then we need that we need to know that what is done, that it's done correct, and that's because of the approach we have. So, first of all, that is very academic, and you have to be very clever to use it. Well, if I can use it, well, then so can you. And yes, it is original academic. In the 80s, there were all kinds of research places, and they were researching functional programming. And somewhere in the 90s, all these research groups all over the world, they combined their efforts and they started to define what is a functional language, which is now called Haskell. But nowadays, a lot of it's used quite a lot, and you don't have to be a rocket scientist to use it. So you don't have to. It could help, of course, but
a lot of people
yeah.
I don't programming.
I don't want to make a point about that. That's inside joke. Difficult. Well, that can be split out in several types. It's difficult to learn. Well, it's got a learning curve. More about that, which is probably due to the fact that functional programming is pretty different from well, what you guys probably call regular programming. On the other hand, I mean, if you're used to functional programming, it's got a lot of benefits, and I know a few people that when they're used to this kind of thinking that functional programming has, that they can let it go and go back to other kinds of programming.
I think that's already
Yeah, so we're
reaching to the choir.
yeah. Yeah. Well, it's different, and because it's very different, well, it really depends on the expectations. If you have somebody that's a senior software engineer who knows only C# or Java or whatever languages you have, then, or maybe quite a lot of languages, then it's well, then they might think, well, okay, Haskell just another language. I'll just do that and give me a couple of days, and then I can write Haskell code from one day to the other. Just another way of thinking. So the expectations people have also contributes to the fact that people think it's difficult. I think this says it all. Functional programming isn't difficult. It's simple. The core ideas in it, it really isn't hard. But it enables you to do all kinds of abstractions. And some of these abstractions can be pretty tough. Interesting though, but very tough. All kinds of things in Haskell that takes just a while to get used to, and even then, I mean, I do now about well, 8-9 years about I program in Haskell, not full-time job of course, but that's what I do, and every time I learn new things. Yeah, I could, but I didn't. I don't have the examples with me right now. So I mean, that's yeah. Sorry about it. Maybe another time. On the other hand, this summer I gave an introduction in functional programming, which maybe some of you. Oh yeah. So yeah. So people that are if some people are interested, I could do that again. Then we could spend a day just to do this functional programming in Haskell thing. Yeah. But I mean, I think it's really interesting and worthwhile to learn. Some of the main features in functional programming, and Haskell is a well, maybe Scala is good too, I mean, but I mean, well, sorry. Haskell is really cool. One of the main things in Haskell, there's a very nice distinction between pure code and non-pure code. Which is very nice feature because pure code is code that's, well, of course, Haskell functional programming, the name says it, functions are key citizens of the language. So, well, everything is a function in Haskell. and functions are defined by you put something in, and then the function does its job, and something comes out. And if you put something in again, then the same thing will come out again. I mean, there's nothing, that's just the way it is, it's the way functions work. And that makes that if you do it's only pure function, then, well, they have no side effects, which would be very interesting if you program and your program would not have any side effects at all. Then the only thing that could happen is that the core of your machine gets hot, and even that can happen, because that is a side effect too. So you need non-pure stuff as well. And the nice thing is, every Haskell program is a non-pure thing because it has side effects. So this main typing I will show is the type of every Haskell program. The main, it's just the hit of the program, just like in other languages too. And it says, well, it's the type, it says it's type IO, and it doesn't produce something void. Well, the fact that this nice distinction is that you can really reason well about the pure code, and it's very Haskell helps you to make this distinction between the pure and the non-pure code. So yes, you have to read something from the database, and yes, you have to read something to the output, but you can encapsulate that and put it where it belongs, just at the edges of what you're really doing, the algorithms and the transformations and all that kind of stuff. Then you can do these algorithms, transformations in pure code, and that helps you to reason about the code. And reasoning about the code also helps to proving that the code is correct, and you get concise code, which means it's readable and it's easy to change. Even it's safe to refactor, because the function, if it's used somewhere, you can replace it you can easily replace it without breaking stuff. You have to guarantee that it doesn't break, which is very, very good. So there's some safety in refactoring. And of course it helps with reuse, stuff like that. So, and then we have, of course, static typing. And Haskell has everything in Haskell has a type. And there's a really nice inference system in Haskell, so you don't have to write the types yourself, but Haskell will infer all the types of your code. And as long as there's no inference, then the code won't compile. You get an error message, and these error messages are, the myth about it is that they're very hard to read. And yes, at first they're really elaborate, and but if you get used to it, they're really spot on. So that's good. And another, the really cool thing I think about this type system is that it helps you in ordering your. So this is great, and doing stuff at the right place. And also, it's if it doesn't compile, then there's something still have to think about. And it really takes care of a lot of errors. So that means that yes, testing still is important, of course, but a lot of kinds of bugs that normally get onto in the process are just altered by the type system. It's just impossible to make some kind of bugs and let them go in the face of the user. which I think is really cool. So because you have purity that enables the, the language to be lazy. And laziness is very, well, that's my favorite feature of Haskell. It's laziness makes that you can reason with infinite lists, with without it also makes that the code can become fast because only the stuff that really needs to help to what you're trying to achieve, the runtime, is being evaluated. The purity also helps in doing concurrence stuff. And so that's, of course, in theory, it's nice to play with, but for any language, you can only use it in real life if there are a lot of libraries, stuff like that. And there's really a big bunch of libraries, a lot of them open source, and there's also a Haskell-specific search engine based on types. So if there is any function you think, well, I need something like this, but probably someone else already wrote something like that, then you can just write down the types, the type of the function you need, and you can just Google it, and then you get a list of functions that from these libraries. So
basically discovered site where you can search for the signatures of Scala functions.
Oh, that's really cool. Yeah. Yeah. Because normally if you have libraries, then either you have to know the library, but if you don't know, how are you ever going to find it if there's trillions of libraries? It's a problem in languages like Java. Well, last but not least, there's a really active community. Quite a few businesses use Haskell. The big ones, and then now not so big ones, they might become big. I'm sure I think Facebook is using Haskell for its, that's nice to know. It's using Haskell to do prevention of spammers, to hold them out. And that's really, well, all these events that Facebook gets, I mean, they have 1.4 billion users. Well, and most of them, I imagine, well, they might use Facebook. Yeah, still. So they do
There's just the
Cura or something. What?
there's just the assimilated by Palantir.
Yeah, this is Silk Local.
Ah,
That's, well, just how you look at it, it's a problem startups in Haskell. I mean, they get assimilated. Anyway, but also these well, the huge guys, the Facebook, the Google, the Microsoft, they use it. Microsoft, a lot of people that were in that helped develop GHC, that's the by now the compiler of Haskell. They are at Microsoft Research. Well, in the end of the talk, I also promised to just have a lot of have a small stuff where we really believe that if you want to do things right, you don't only think about the programming language you write writing, but also you want to produce the software. You have to do quality. So that means continuous integration, stuff like that, and documentation, which isn't our focus. Well, these some of the tools we use. Particularly, of course, well, the nice features they have, certain management service and failure to build the stuff every time you check in. And we have a regression test set, so yes, we also make errors, not as much as an average coder because we have this nice type system. But still we have, so we try to catch a lot from the regression tests.
What icon you draw?
That's Waffle. Waffle is a tool it's about Scrum work. I mean, all the it is a it has an integration with Ticket. So if you have issues or stuff like that with Ticket, then well they just have a Scrum board made out of it. It's really nice feature. Waffle.io. So well, short presentation. I hope that the point I'd like to make is, well, just as a developer, whatever software it is you make, think about what tools you use and the approach you take, and don't just code for whatever language it is you do, and don't think about new tools, new platforms, continuous integration, functional programming of class. So yeah, keep learning. Oh, something wrong with that sheet. Sorry. Well, anyway, I should be findable.
It's good. On the stream, it's good.
Oh, okay. Maybe any questions, comments? Mm-hmm. Yeah, well, these rules are based on we do derive the rules and we can put that into software. But if you only have rules, then what you have the approach is you have a just let's say a database, which all the business which could contain all the business data, and then on top of that is a layer of these rules. So and but then we have this service layer. But to make that usable, of course, you also need a client layer, which is not derived exactly. Well, it is derived from the specification. We have now features in the language also to specify the client interface, but that's it's not production ready. So there's still work to be done to enable this to be production ready. And then on the other hand, in this approach, we think of the business data as one cloud of business data, but in the prototype we have reduced that to just one database, which isn't really production-like. So one of the next steps we're looking to is to take the business data not from just one database, but from all kind of sources, to integrate that in the rule checks we have. So yes, there's a lot of.
Almost 7,000 comments.
Oh, that's possible. Too much, I think.
Is there any code you can just open on GitHub right now and zoom into, or is it all bit
Yeah, I mean, we can have a look.
Yeah, just some.
Now let's see. Where's my? Oh, that is onhandig.
22,000 lines of code in Haskell, 40,000 of JavaScript, and almost 60,000 lines of code of PHP.
Let's see. I don't see my
No
mouse.
TypeScript in there.
That's my mouse name.
I see a mission for you there, Joost.
Yeah.
Ik zie mijn muis niet meer.
Perhaps you need to hit escape to end your presentation. Oh, there it is.
Yeah, it's on the bar.
Yeah. It's all just look into some code, and I haven't prepared this, so this is just we'll just see what happens. Let's do not. And what you see here in Haskell, it's a class, but class is not something like Java. I've heard, I don't speak Java, so I don't know, but I've heard people say this could be compared more or less with an interface in Java. But I don't know what they say now. It says, in fact, that there is a class of types that you can have, and if you make a type an element of that class, then that class, such a type will have these functions to it. So, for instance, if I would say a collection of string, then I can use these functions on a string. So then I have a collection of strings, whatever meaning is it. Well, yeah. This here it says, well, a list. This is the A list is here made an instance of collection. So that means you can have a collection of lists over here. So that means if we have a list, we can say, well, we can use this function lm, which is, well, lm in list, so that's pretty straightforward. But we could also say the union of two lists is the first list concatenated to the list that is the second list without the elements of the first list, because this element is without this one, and it says, well, the first list without the second list, that is all elements of the first list, or access to elements of the first list that are not a member, well, of the second list as well. There's zillions of more code to inspect, so I mean, it's all on GitHub, so feel free. Okay, that's it. I don't know if there are any more questions. Okay, thank you for having me.